So in the last video, I said we're going to be graphing next, but I lied. I wanted to spend a little bit more time on domain and range, and it's worth making a separate video for that. So if we're looking at something like this, which we had in the last video, we're at a list of points, and you recall I split up my x and y values. So by doing this, I actually found my domain and my range. Domain, or just call that D, that's a set of all x values. So for this list of point, all the x values would be those numbers, -2, -1, 0, 1, and 2. And when I write a domain or a range, the set of numbers, I separate everything with a comma. It's very useful to put everything in numerical order. This helps you find your mistakes, and it helps me make sure that you got everything when I'm grading a test. And if there's any duplicates in either a domain or range, which can happen, it might not be a function if there's duplicates, but the range is okay, but the domain, you can't have duplicates. You don't write them. You only write one number one. So if -1 shows up twice in a set, you only write it once. So if I'm asked to find the domain and range of a set of points, all the x values go into the domain. I put them in order. I avoid any duplicates. And the range, all the y values, I put them in order. And I avoid any duplicates. The other thing would be graphing. We're not going to get too crazy. I want to talk about some basics. So if I have a linear equation or a linear function, I graph it, and it has a slope that's, well, we don't know what slope is yet. If it's going on an angle, so to speak, the domain and range are going to be all real numbers for each. So I'm talking about the domain of a linear function, and I'm just given a graph. I can plug in any x value, and it's going to give me a y value. And so my x values, I can plug in any x value, so it means I'm going from negative infinity to infinity. You might also see this, x is a real number. And this funny looking E here, that's a Greek letter epsilon, and that is kind of universal. That means set containment. So that means x belongs to, I'm sorry, set membership. X belongs to this set that's over here. Y belongs to the set that's over here. We can rewrite that as x belongs to a set of real numbers, which is any number, positive, negative, fraction, decimal, whatever we want. If I'm looking at a circle, so if I'm looking at a circle, and I kind of sketch one really quickly here, the domain would be all the possible x values that can occur. And so what I'm looking for is I'm looking for an x value, or I'm looking at the x-axis, and I'm looking, are there any y values that correspond to any of those points? And I notice that when I'm drawing a circle, my x values on the circle are going to lie between -3 and 3. They're going to include, so x belongs to -3 to 3. And when I'm looking vertically here, my y values are going to look the same way. And that's how I tell domain and range with graphs. This is a function, the circle is not. But relations, which a circle is a relation, they have domain and range too. It's just not a function.